Welcome back. In our previous lesson, we explored what machine learning is, how it fits into artificial intelligence, and where deep learning comes into play. Now that you've got the big picture, it's time to dive deeper. Machine learning isn't just one single method or approach. In fact, it comes in different forms, each with its own strengths, limitations, and best uses. Think of it like learning styles in people. Some people learn by being told the right answer. Others figure things out by exploring without guidance. And some learn best by trial and error. In machine learning, we see similar patterns, and that's why we classify ML into three main types: supervised learning, unsupervised learning, and reinforcement learning. In this lesson, we look at what each type means, how it works, and when to use it. All with simple, clear examples so you can remember them long after the lesson is over. By the end of this lesson, you will understand the three main types of machine learning and how they differ, learn how each type works through everyday, easy-to-follow examples, and be able to recognize when and why you might choose one type over the other. Let's begin by understanding why we even have different types of ML in the first place. Not all problems are the same, and not all data is the same either. Sometimes we have labeled data, meaning we know both the input and the correct answer. Other times we have a pile of data but no answers to match it with. And in certain cases, the learning happens through interaction, much like how a robot or a game bot learns from experience. These differences in problem type and data availability are what lead to the three major categories of machine learning. Let's start with the first one, supervised learning. In supervised learning, your data comes with both inputs and outputs already labeled. Think of it like having a teacher who provides the correct answer for each question in the practice test. The algorithm studies these examples, and over time, it learns how to produce the right answers for new, unseen data. For example, if you want to predict house prices, you might have a dataset that includes the size of the house, its location, and the selling price. The model learns the relationship between size and price, and then it can predict the price of a new house just from its size. Supervised learning shows up everywhere. Your email spam filter is a classic example. It learns to classify messages as spam or not spam by looking at past labeled examples. In education, it could predict a student's exam score based on how many hours they studied, using data from past students. And in computer vision, it can classify pictures, for instance, deciding whether an image contains a cat or a dog based on thousands of labeled animal photos. Now let's visualize how that works. Picture this. You feed the model with your input features, like square footage and location, along with the correct outputs, the actual prices. The model processes these examples and learns the connection. When you later give it a house's square footage and location without the price, it uses what it learned to predict the price. The direction is clear, and the answers in the training data are already known. Now let's shift gears. In unsupervised learning, your data has no labels. You don't tell the model what the right answer is. Instead, you ask it to find patterns or groupings on its own. It's like giving a student a stack of books with no categories written on them, and asking them to sort them in a way that makes sense. For example, a business might read customer purchase history into an ML model without specifying any categories. The model might discover that certain customers tend to buy similar products, grouping them naturally. Unsupervised learning is widely used in customer segmentation, grouping customers based on similarities in their behavior or preferences. It also plays a big role in market basket analysis, where retailers find which products are often bought together. And in data science, it's often used to reduce noise in large data sets, making the data cleaner and easier to work with for other tasks. Imagine a scatter plot with hundreds of data points representing customers. At first glance, it looks like a random cloud of points. The algorithm steps in and identifies natural clusters. Maybe one cluster is frequent shoppers, another is occasional buyers, and another prefers specific categories. No one told the algorithm which group is which. It figured it out by itself. The third type is reinforcement learning, which is a bit different from the first two. Here, learning happens through interaction with an environment. The model, or agent, makes decisions, receives feedback in the form of rewards or penalties, and adjusts its strategy over time. Think about a robot learning to walk. At first, it stumbles. But each time it moves in a way that keeps it balanced, it gets a reward. And when it falls, it gets a penalty. Over time, it figures out how to walk better. Reinforcement learning is all about trial and error. The agent tries an action, sees the outcome, and uses that feedback to improve future decisions. Over many iterations, it learns which actions lead to better results and avoids actions that lead to poor outcomes. You'll see reinforcement learning in self-driving cars, which constantly adjust based on road conditions, other vehicles, and safety rules. It's also behind game-playing bots like AlphaGo, which master the game of Go by playing millions of matches and refining a strategy. And in robotics and industrial automation, RL is used to optimize how machines move, handle materials, or even manage factory workflows. Let's put it all together in a quick comparison. In supervised learning, data has labels, learns from known answers, like spam detection. In unsupervised learning, no labels, finds hidden patterns, and likes grouping customers. In reinforcement learning, learns from rewards or penalties, like game-playing agents. Now, when do we use each type? You choose supervised learning when you have historical data with known answers, like predicting prices or classifications. Go with unsupervised learning when you're exploring data and don't know what patterns might be there. And choose reinforcement learning when the learning process depends on outcomes over time, and the system can improve by interacting with its environment. Think of supervised learning like a teacher giving you the correct answers while you practice. Unsupervised learning is like sorting books by theme when there are no labels on the covers. Reinforcement learning is like learning to ride a bike. You figure it out by trying, falling, and adjusting until you can balance. Here's a quick visual reminder. Supervised is target available. Unsupervised, you find structure. Reinforcement is learn by doing. Let's now recap the essentials. Supervised learning needs labeled data to work. Unsupervised learning works with unlabeled data to find patterns. Reinforcement learning learns through rewards and penalties. Each ML type hits different problem types. Real-world examples help you quickly identify which type to use. Before we finish, think about these. What does supervised learning need to work? Which ML type is used when there are no labels? What makes reinforcement learning different from the other two? Can you name one real-life example for each ML type? When would you choose unsupervised learning? Take a moment to reflect before moving on. If you're ready to explore these topics more deeply, here are recommended resources you can use. And that wraps up this lesson. You now know the three main types, what they mean, how they work, and when to use them. You've seen practical examples for each, and you can now start recognizing which approach fits different kinds of problems. Thanks again for learning with us. I'll see you in the next lesson.